Welcome to the Haley Cruise, a data collection mission in the Pacific Ocean whose main objective is understanding how ocean circulation interacts with the climate. To understand why a crew of intelligent scientists and sailors are traveling to the middle of nowhere to drop expensive equipment into the far depths of the ocean, we need to first meet neodymium. Much like injectable dyes are used to get clear MRI readings for doctors, neodymium traces water circulation for our scientists. To illustrate the current water circulation theory, this is the Atlantic Ocean water basin. On the left, represented in blue, we have the North Atlantic Deep Water Current System, NADW, with an isotope signature of -13. On the right, represented in yellow, is the Antarctic Bottom Water, AABW, with an isotope signature of -9. Most textbooks will say the neodymium we are finding in these water masses are runoff from the land, but our dear scientists believe there are some holes in that theory. To research their new theory and measure ocean behavior, we've been sending down the multi-core to extract sediment from the ocean floor. We then break down each core into layers representing a segment of time, much like the rings on a tree, each layer reflecting the water circulation at that particular time. Scientists can then reconstruct the currents by the amount of neodymium we find in each layer. Let's say I collect a water sample from the sea floor, 5,300 meters deep, with a -11 ND signal and a -13 ND signal from a pore water sample collected 25 centimeters in the sediment dated 20,000 years ago. The water mass force fluctuates. Sometimes the force from the north is greater, sometimes it is greater from the south. The green represents where they are mixing. While these water masses are going back and forth, the ocean floor passively receives ND markers reflecting the water's state at that time. The water I measured at the sea floor is a mix of 50% AABW and 50% NADW. This shows us the deep water circulation is currently equally strong from north to south, while the older sample, 25 centimeters deep in the sediment, shows a much stronger ND signal, telling us the circulation from the north was strong 20,000 years ago.
That's the classic theory. Now here's the twist.
Our scientists believe water masses do not get all their ND signals from the surface and runoff water. Instead, they think the water mass is receiving ND signals from the ocean floor. For example, let's say I take a sediment sample of -11 ND. Classic theory would say that's an equal flow from north and south. With the new theory, adding the sedimentary ND source, we might interpret the signal of -11 as indicating only a southward flow of NADW, and AABW was simply not there at all, a completely different circulation pattern. This would mean the ocean floor isn't a passive receiver, but a very active component to the equation.
And the coolest part? They're not exactly sure why they're getting these readings. It's a complete mystery. It opens the door to numerous possibilities. Very exciting news for curious scientists out there.
This research is giving us a deeper understanding of ocean circulation. The sea not only stores and redistributes heat, but also important greenhouse gases like carbon dioxide. The more we understand this relationship, the better equipped we are to help our dynamic yet fragile planet.